We're going to use the following simulation with the forces in motion data collection and processing activity that is found on the student DCP Google site. There are many different activities within this simulation, but for the purpose of this DCP activity, we're going to focus on the friction simulation, which is a horizontal surface, a movable crate, and a stick person that can move the crate either left or right. For the purpose of this investigation, we're going to look at the relationship between the reaction force of the crate, or the normal force, and the friction force, which at the moment isn't shown. To do this, we have control over 5 sliders below the simulation. The first slider we're going to manipulate is gravity, which is at the moment is set at 9.8 meters per second, which is the gravity on Earth. To make the math simple, we're going to set this to 10, and once we've done this, we're not going to touch this slider, and this is going to remain constant throughout the whole of the activity. Above the gravity is object mass. The object mass in this investigation is the independent variable. That is, it is the variable you have control over. You'll be asked to set the object masses at different specified values. You can then see these specified values in the box to the right and record this value down with suitable error. If I increase the object mass, the force due to gravity, Fg, and the reaction force, or the normal force, Fn, both increase. If I decrease the mass, then they both decrease, and they increase and decrease proportionally, therefore they are balanced because they are in the opposite direction to one another. Above this, you'll see kinetic friction and static friction. For the purpose of this investigation, we are not going to differentiate between the two. We're going to assume them to be the same and call them, therefore, the coefficient of friction. At any point throughout this investigation, both the kinetic friction and static friction must be the same value. So we must set them both to be in the same value, and if we look at the right-hand side boxes, these two values must be the same. You'll be asked to move these frictions to different values throughout the investigation. However, at any point, whether I increase or decrease these values, these numbers on the right-hand side should always be the same. Your teacher may want to come back and look at the difference between static and kinetic friction at some other later date, but for the purpose of this investigation, we're not going to look at the differences between the two, and we're going to consider them to be the same as I said before. Other things that we can change in this investigation, or in the simulation, is we can apply a free body diagram. This will actually help us to look at the forward force, the applied forces, and the friction forces, which are not shown but will be shown at a later date. We can also use the sum of the forces, which shows the difference between the forward forces and the friction forces. Again, these are not shown. We can change the walls. We're going to leave them as brick. We can also change the position of the crate. We can move the crate right, or we can move the crate left. Personally, I like to keep the crate to the left. The applied force is the dependent variable inside this investigation. As soon as a force is applied to the crate, you can see that there is a friction force that is also being applied as well. If I keep on increasing this, at some point the sum force will start to appear and the box will start to accelerate to the right. You can also see that below there's a playback function. If I go to the playback function and press play, you can see that the activity that I just performed gets shown, and I can record force values that I may have missed. However, for the purpose of this investigation, we need to calculate the maximum friction force. That will therefore be the friction force just as the object starts to move. Therefore, we need to record the friction force whilst the object is moving at constant velocity. To do this, I'm going to first of all reset the record function. I'm going to move the box to the left, and I'm going to apply a force. I'm then going to wait until I can see the sum force. The sum force means acceleration. So if I cancel the sum force by moving the force back a little bit, the force will start to move at constant velocity. Therefore, my applied force, Fa, will be the same as my maximum friction force, Ff, and I can record this value. If I go back to the playback function, I can replay this, and when I replay this, I can wait until my sum force is cancelled out, and this will be my forward force and therefore the friction force that I need to record. One thing that you need to be aware of in this with the dependent variable, the applied force, is that the sensitivity given by this numerical value here is not necessarily the same as the sensitivity of the slider. Therefore, you need to play with this a little bit before you can choose a suitable error that can be logged with your friction forces that you're going to put down. The last thing you need to do for this investigation is go to the instruction manual that you can find attached to this Google site and complete the DCP investigation. Thank you very much.